Good afternoon, students. Now we are going to do experiment number 1, logic gates. The things we should do are, the main thing is to connect the IC in this form, connect pin number 14 to VCC, 7 to ground. So pin numbers are counted from this groove, left of this groove, 1, 2, 3, 4, 5, 6, 7, 8, 7 on this side, and 8 to 8 here, 9, 10, 11, 12, 13, and 14. Now, you're going to use the dip switches, switch 1 and 4. One side is connected to ground, the other side is going to go to this gate, okay, the IC 7404, which is NOT gate. You also need to connect the pull-up resistors 1 kilo ohm and connect it to plus 5 volts power supply. Whenever you see an IC, you'll need to mark the pin numbers, okay. These are TTL ICs. I'm going to show you the TTL pin out, and you're going to write here, like I can say for now, this is pin number 1, this is pin number 2, and connect the cathode of the LED and anode of the LED should go to 330 ohms and it has to go to plus 5 volts power supply. So this is to verify the function of NOT gate. NOT gate has to produce a low output when you give a high at the input, and it should produce a high when you give a low at the input. So the idea is when the switch is open, it is like giving a high to this input, okay, because the current path is from plus 5 volts 1 kilo ohm resistance here when the switch is open, okay. So when you give a 1 here, it is going to show as a 0 here, and when there is a 0, the LED is going to glow because it is going to get forward biased. Plus 5 volts, LED positive, LED negative getting 0 is like connecting it to ground, so the LED will glow. So for you, when the switch is open, right? The switch is open, corresponding to giving a 0 at the input, okay. Now the LED is on, so it is like a low here, it is going to produce a high. Now when the switch is like only one switch for this because there is only one input, right? So when the switch is closed, the current is flowing here, like giving a one. Yeah, that is what I no. When the switch is closed, it is going to connect to ground and it is like giving a 0 to this input, and it is going to produce a 1. The LED is not going to glow, okay. We'll try to do this, and then we are going to do for this circuit, we are going to check the AND gate 7408 AND gate, which has two inputs, SW1 and SW4. This part, the display part, active high display part, we are not going to do anything, like we are going to keep it for checking all the logic ICs, okay. So here you have 7404 with LED, and this here also you have the same. What is different from here to here is this is added in the circuit 7408, which is AND gate, it's added in the circuit. Next is from here on all others are the same. You're only going to take out that IC and change to a new IC and verify the outputs by closing and opening the switches. Now 7432 is OR gate, 7400 is NAND gate, 7402 is NOR gate. For 7408, 7408, 7432, 7400, for all of them, pin numbers 1 and 2 are inputs, 3 is the output, okay. For 740 also 1 is the input, 2 is the output. For this 7402 NOR gate, 1 is the output, 2 and 3 are the inputs. This is because of the pin out. Now, if we could do up to this point, this is also, we can do XOR gate, again 1 and 2 inputs and 3 is the output. So all these gates should be checked. Next is to connect these. Let's see if there is enough time for performing this. Otherwise, even after the class, when you do all of these properly, Even after the class, you can hook up these and you can verify the truth table. Look here. These are the logic IC7404 pin configuration you are supposed to draw. Let me show you on the internet. TTL pinout. It's there in the book. Here you see NAND gate 7400. 1, 2 are the inputs, 3 is the output, 4 and 5 are the input, 6 is the output. When you come to this side, 9 and 10 are inputs, 8 is the output, 11 and 12, 11 is the output, 12, 13 are the inputs. Here VCC is 14, 7 is ground. Okay, there are 4 NAND gates within one IC, right? So we call it as a quad 2 input NAND gate. Okay, quad 2 input NAND gates. Quad to represent 4 gates in there. You call this not IC as hex inverter because there are 6 logic gates within the IC. So here 1, 2, 3, 4 like this, and on this side when you see 9 and 8, 9 is the input, 8 is the output, 11 is the input, 10 is the output, 13 is the input, 12 is the output. This must go onto the result sheet. Okay, VCC 14 is VCC and 7 is ground. Next is look for this is XNOR shown. Here is XOR 7432. Again, you see it's same like this, right? Now, I want to show you I want to show you NOR gate. Look at this NOR gate. NOR gate alone, 1, 2, 3 are the inputs, 1 is the output. It is just reversed with respect to other ICs, okay? So remember that. Next is, here it is like in a kind of nutshell, you have them all. XOR gate, see, you have all of them. NOT gate, AND gate, OR gate, NAND, NOR, and XOR. This is what you want, okay? All of these must go onto your result sheet. I've cut some small wires. Now I'm going to fix the ICs on this breadboard. I have fixed the dip switch. All the switches facing me. I've connected like switches 1 and 4 to ground line. This is the negative power trail, right? The one marked negative. So I've connected it there so that it doesn't disturb me when I connect to the ICs. Now, here to the battery holder ends, I've connected the red and black alligator clip wires, the jumpers, and I'm going to connect to my negative and positive power rails. Here, red wire here, and black here, and this is my battery. 3 battery holder. I fill the batteries there. I fix the batteries and I'm connecting it here. Now, so the battery has come to these 2 places. Now I'm going to check the function of 7404. This is NOT gate, right? From this pack, you should take 7404. I think this camera is helping to get the numbers. Otherwise, you may have to read it using a magnifying glass, okay? So here I see this, the first one is 7400. I think the second one is, wait, 7432 I found 7432. I should keep it because it's hard for me to read. So I'll take it and keep it. This is my 7432. And whenever you take the IC, they will be little like the pins will be a little farther. They may not go exactly and sit on the breadboard slots. So make it to 90 degrees and then fix. Now it is nicely fixed. Okay. So this is my 7432. Next, I'm looking for 7404. 7408 I found here. So this also I will keep it. 74008. This is 7408. I'm just keeping it. Maybe I'll keep it somewhere. Next 7404. Here I found 7404. 74HC04. Okay, these are HC family ICs. 7404 is here. I'm taking it. Okay, I'm confident. So see the place where I'm fixing on the breadboard. It doesn't go, as I said. You have to adjust it to exactly like 90 degrees. You press a bit, that's it. And fix it little farther from the dip switch. You know, the reason is this is 743208. I'm keeping 7432. I'm keeping. See, I have fixed it little farther from the dip switch because I'm going to connect all the ICs to be tested in between. Okay, so first will be this. Now I have to take an LED. You can keep the logic circuit maybe on your screen and you can work on, because I need to show you the working. I'm not able to show you the diagram, but I'm also going to keep it on my second screen. Okay. Here I'm connecting. See the LED positive is long end, LED negative is the short end. Okay, so the short end has to go to pin number 2 of this. Okay, pin number 2 of this. So for reading the pin out of this, what I do, I go and the groove is placed this side, and I start reading the pins from here. 1 2 3 4 5 6 7. Before doing anything, what I'm going to do, I'm going to connect pin number 7 to ground and 14 to VCC. Okay, so for doing that, I have those small, extremely small wires. Now, what do I do to this small wire? See here, I take it like I do for a resistor. All right, see, now this is my wire. Now, pin number 7 is ground, right? So pin number 7 here, see, pin number 7, and just whatever I do to my IC, I do for this wire also, so that it sits comfortably without disturbing any other connection. So pin number 7 is grounded. Next, pin number 14 to VCC. So take this wire, bend it at right angle 90 degrees, and pin number 14. Okay, this is on the negative power rail, and I have connected my positive here. So pin number 14 should go to positive power rail. So pin number 14 I connected it. Pin number 14 is connected to that. One thing what I need to do is, I have not connected the negative line from this side to here, right? So let me do it with another black wire. See, I don't want this length. I'm cutting it here because I just want to fix it nicely, okay? So I put one point here and here I want, right? So I want only this much length. I'm connecting from here till this side, negative. Yeah, still my measurement was not exact, but it's okay, right? Here. So the idea is negative power rail from this side has to be connected to the negative power rail here because my negative of the power supply is here. Okay. Now have to start making other connections. So what are the other connections? The switch, right? One end of the switch is already grounded. The other end of the switch should get pull-up resistor and it has to go to plus 5 volts power supply. So pull-up resistor, 1 kilo ohm pull-up resistor. Right? So go to your resistance packet. Take 1 kilo ohm resistance, brown, black, red. Brown, black, red. Again, since I'm bending it fresh, I know the distance is this much, so I can go closer. And bend it like this. Okay, now I'm going to check, like switch 1 has to be getting this, so switch 1 is here. The other end goes to plus 5 volts. See, switch 1, one end of switch 1 is here. This is switch 1. You can even lift it and see if you're connecting at the right point. Okay, see, when you move it, you see the pins. So I see the pin there, and the same line should be the first end of the resistor. So I'm okay, I've connected it at the right place. I have kept some space in between like the switch and this resistor because I want to connect some wire that has to go to this side, pin number 1. Okay, so here, next is another resistor. That is to be connected to the other side of switch 4. Switch 4. So 1, 2, 3, 4. Switch 4, and the other end goes to positive of the power supply. See that you don't short circuit the ends of these ends of the resistors, because other end going to power supply positive, it could be short circuited, doesn't matter because they are the same end, right? But here you see, you don't short circuit these two ends. Next is, from here I should use, for the inputs to ICs, I'm going to connect white wires. Okay, the input I can choose colors, right? So what I'm doing from here, I need to connect to switch 1, pin number 1, right? So this length is not okay, so I take from here to switch 1. Finished. Next is, I don't have to, this is just NOT gate, right? So one input will do. And for the second input, the pin number 2 has to go to negative of the LED. So I'll just fix the LED at a different point on the breadboard. Negative, again see negative, I'm connecting here to the first, the left hand side, and on the right hand side I've connected the positive. Now from for the outputs, I'm going to use green color wire. Okay, see, this is my pin number 2. It has to connect to negative of the LED. Pin number 2 is going to negative of the LED, negative of the LED. Next, what should be connected to positive of the LED? Positive of the LED should get a 330 ohms resistance and go to power supply positive, 330 ohms. Orange, orange, brown, 330 ohms. There are no much categories in your resistance kit, because we need like 1 kilo ohm and 330 ohms mostly. So we only have those. So here I'm taking a 330 ohms resistor, orange, orange, brown. I'm connecting it here to a different point, and I'm going to connect to ground. Okay, again I'm going to use a small wire, extremely small wire. So this negative positive connections are fixed nicely on the board, so they don't disturb my other connections. Okay, it's intact. So where is it connected? It's in line with the second end of the resistor. This one is in line with the negative, and it is going to negative power tool. Even these wires, I'm going to cut short for showing you clearly, okay? If it is looking like a loop for you, doesn't matter. No, but for me, I have to show you clearly, so I'm doing this, okay? Or if you're happy with this kind of building the circuit, it's okay, you can do it also. See, I have connected it with the second end of the anode of the LED, and then the other end going to the negative of the yeah, it should go to positive of the power supply, right? This one, The other end of the LED should be connected to positive of the power supply. So this is not the right wire here. Positive I have connected, power rail I have connected. But one thing is, I need to connect from this side positive to this side positive so that they communicate, right? Here, and this has to go to here. So I'm going to cut here and bend the wire. Make these connections. Connections are finished. Switch is now closed. Okay, switch is closed. Switch is closed. So all the voltage from here, from the power supply, are going through the resistors to the switches and grounded. Okay. When I open the switch, the LED is glowing. Externally seeing, when you open, the LED is on. When you close, the LED is off. Try this circuit. Yeah, to show that when the switch is open, there is a high voltage. At pin number 2, I connected this LED. Just for checking, like I'm trying to use it like logic probe. Okay, I can know the state of the input and output pins. Okay, with this LED, careful, huh? Do it carefully. It is not going to harm you. See, pin number 2 is a 1. Okay. I have given a 0 here. I have given a 0 here. See, pin number 1. Pin number 1 is a 0, right? Pin number Pin number 1. Pin number 1 is a 0. Pin number 2 is a 1. Pin number 3 is a 0. Pin number 4 is a 1 because it is like, see, this is a 1. So every gate will be working for the same circuit, okay? But we are checking just gate 1, okay? Next, pin number 5 is what? Pin number 5 is a 0, right? Pin number 5 is a 0. What is pin number 6? Pin number 6 is going to be a 1, right? Pin number 6 is a 1. 7 is grounded. 7 is grounded. Pin number 8 is the output, right? Pin number 8 should be what? 1. Pin number 9 is here, these are all going this way, and this side, it is going to be like 9 is the input, 8 is the output, right? So at the output pin, whenever I connect, get the value, or like I get a glow or no glow to say about the state of the LED. See, it's like it should be a 1. It's a 1, right? Properly, if you connect, it's a 1. So next, this pin is a 0. This pin is 0. Next pin is going to be a 1. The LED terminals are really small. Oh yeah, I can do this. I don't have to go there. Exactly opposite to that pin. I can even do one thing. I can connect it comfortably across the power supply, positive end to one side and negative to the, like, a different, an arbitrary pin. And then I can connect that pin to ground. I can go from each of the pins and connect it there and see. Okay, just this is pin number 8, right? Pin number 8, when I connect to this, it's on. Next, pin number 9. Pin number 9, when I connect to this, it's off. Pin number 10 should be on. So if I don't find the LED glowing, I can say that it's not working. Okay, those gates are not working. Yeah, this is working. So 13 is the input, 12 is the output. Here, this is the input. Okay, this is the output. It's working. And this is the input. Input is low, output is high. So all the LEDs have worked. This is just an extra, it's not there in the circuit. Okay, I showed you how you can test the outputs of all the gates within the IC just using an LED and like in forward bias condition. Are you done with it? Can you share your screen? Like, can you share your work with me? I'll allow you to share screen through your webcam. Who wants to show first? When I open the switch, also I can do the same testing. Pin number 1 is high. Pin number 2 is low. Because active high display you're using. Three is low. Number 4 is not able to comfortably connect. So don't worry, leave it. So when you open the switch, LED should come up. When you close the switch, LED should switch off. Are you all doing with me? Is there any difficulty, guys? How many of you are trying? Yeah, beyond. Oh, good. So now open the switch.
It's open, madam.
When you open the switch, also the LED is glowing.
Yes.
Because it is getting the power supply even without connecting the switch properly. Press the switch a bit, press it a bit. See,
Yes.
right?
Yes.
That is the short, and it is not connected.
Oh.
Yeah, it should not glow for both the cases. If it is glowing, the switch is not in circuit. So see if you have short power, like the other ends are going to ground and these ends are going to the power supply with resistors. My LED. Akhil Shah. One second, one second. Now I'm going to proceed to checking the AND gate function. Before making any changes in the connection, what I did, I removed from here, from the positive of the battery, I just opened this clip. It's for safety, you can open this also, take it out, take out the battery connection. Now I'm going to, instead of connecting this white wire to the input of the NOT gate, I'm going to take it out. I'm going to take it out and I'm going to fix my 7408 in between. Output pin number 3 of the 7408 should go to pin number 1 of the 7404 NOT gate. Okay. So the inputs for the AND gate are from the switches 1 and 4. Let me show you. 7408. I can. Yeah, now I can read it. 7408, clear, right? So I fix it. Did you all download this Irion camera? I fixed it. So I'm going to use wires to connect from the switches. So I have to get pin number 1. Okay. First switch to pin number 1. Second switch to pin number 2. Second switch. Okay, see where I'm connecting, okay? See, switch 2 is here, right? So in line with the resistor's first end, I connect a wire which is going to pin number 2 of the AND gate 7408, and this point is going the same, like you can see. Maybe I shall show you close like that. Do you see it? They are in line. These two are in line, and this wire and this resistor are in line. Okay, and then see the point I have connected. The first switch going to pin number 1, second switch going to pin number 2. Now pin number 3 has to go to pin number 1 of 7404. So it's an output from 7408 to the input of this 7404. So let me use a different color. I'm using this color to send it to. See, this is pin number 3 going to pin number 1 of 7404. Okay. Now, one thing what I did not do is to power on this IC. How to power on this IC? Pin number 7 to ground, 14 to VCC. So pin number 7 to ground, pin number 7 to ground, 14 to VCC. Put into VCC. Now I have powered on. So now see the positive of the power supply, the battery pack, it's going here, and negative is here, it's going here. Now both the switches are closed, right? Both the switches are closed. So I have applied 0 and 0 to the inputs, 1 and 2 of the AND gate. So this is going to produce a 0 only. So it is producing a 1 here, which is not forward biasing the LED, so it's not glowing. Okay. Now, when I would change pin number switch 1. Wait a second. It's acting like an OR gate. Let me see if I have put 7432. 7408, we read it clearly. 74LS. 74, let's see. Zero, eight, nine. I open the switch, I give a 1. I have to do this. Oh, this also a 1. 1, 1, 2, 3. 1 second. I have done something for switch 4 not connected properly. Okay, switch 4 is not connected properly because see here 1 is okay. This is pin number, this is switch number 4. I've connected 1 after, so maybe that is causing. Okay, so what I'm going to do, I'll take it and I'll fix here 1 pin before, because that switch is not connected in the circuit because the negative is not connected properly. Now it should work. Huh? Let's see. This is both close, 0 and 0, 1 and 0, 0 and 1, 1 and 1. Yeah, now it's okay. Because the switch was not properly connected, it was behaving like an OR gate, which would produce a high for any of the input high. The hanging inputs are 1. So therefore, it was taking a 1 from the other switch. Okay, though since it was not connected properly, grounded properly. This side, switch number 4 is getting this resistor okay, but this side, I had connected this wire to 5. So I was trying with 4 and it didn't match properly, sync properly. So then now here it is okay. So see, 0, 1. Okay, 0, 1, it's not glowing. 0, 0, it's not glowing. 1, 0, it's not glowing. 1, 1, 1, 1, it's glowing. So this is AND gate function. Whenever the output is not okay, the mistake you would do would be the power connection or the switch connection. Okay, check the switch connection or the power connection, then the circuit must work. Other than that, you won't do any mistakes because the pin numbers, we won't do mistake in counting them. Input output pins, we won't do mistakes because we are taking from the data sheet. So none of those would be a problem excepting connecting, like just simple connection error, ground connection was wrong. So it was behaving wrong. Now, if you do it and show me, it would be like, okay to proceed to the next. After finishing every part, take a picture, okay? Like for one of the states, one state, for all of them, for one state, you take picture.
Hello, ma'am. Can I show it to you?
Yes, please. Yes, this is 0 0 state. Ah, okay, this is, yeah, 1 0 state. 1 1 state is glowing, yes. 0 0, both 0. Yeah, good. Good. Perfect, Akhil Shah. You're done for AND gate. Now change this IC. Change this IC to 7432 and try.
Okay, okay.
And power off, okay? Take off the battery and then continue.
7038. Which one, ma'am?
For when you're making connection for 7432, remove the battery connection and then change the IC and then reconnect back the battery and try.
So
Okay.
remove the 7408 and put.
Yeah, you have to remove 7408. Yes.
Okay.
Yeah, both 1, right? Now
Yes.
1 0, 1 0. Make it to
Yes.
1.
1 0.
1 0 is also on. Yeah, good. 0 0. Good. That's it. You're done. Now I'm going to go for, see, I'm removing the battery. Okay, I've removed the battery and let me put the switches to close and close. Okay, now I shall change this. Now I can use this tip to remove carefully. Okay, this is 7408. I'm keeping it back in place. Now 7432.
Ma'am, will the connections will be same as the last one?
All same because there is no change in the pin numbers, right? So all same. So only for 7402 we are going to make changes. Now 7432 the same, 7400 same, 7486 the same, all same. Just change the IC and test with the like connect the power back and test it. Finished. So now this is 0 0. Now 0 1 LED is glowing. Next put it back. 1 1 0 LED is on. 1 1 LED is on. This is the function of the OR gate. Next, after doing it, put it back to 0 0. Okay, and then power off from here, power off from here, and change the IC. Either pencil or your nose pliers tip can help in taking the IC off. 7432 is done. Next is 7400. Okay, 7400. Top one. This one. So take it. 7400. Adjust the legs or pins. No change in connection. Pin number 1 is input, 2 is input, 3 is output, all the same. So put it back here. Now NAND gate, right? NAND gate, both low is high. Now 0 1 is also high. 1 0 is also high. 1 1 1 1 is a low. Just opposite of AND gate, right? So both 1 and 1 is 0. Only then. All other times when there is a 0 in any of the inputs of the NAND gate, the output is a high. Both low is okay, good. Both are low and it's a high. NAND gate is finished. After finishing NAND gate, remove the connection of the power supply only. Take it out. Take it out. Next is, I'll check 7486 because that pin configuration is the same, right? I won't go for 7402. I'll keep it as last, okay? Because pin numbers has to be changed. 7402 is here, 7486. Here, I find it. 7486. For 7486, any difference in input should cause the LED glow, right? A high should be produced. Just be careful about the pins because it might easily break, bend. Seven four eight six. No power connection. Now both are same inputs, low and low. Low and low. Now low, high, the LED is glowing. High, high, the LED is off. High, low, the LED is on. So I have tested 7486. Now I checked 74081 gate, 74321 gate, 74001 gate, 74861 gate. That is pin number 1 and 2 as inputs and 3 is the output. One of the quad 2 input ICs I have checked. One gate of each of the IC I have checked. Now I'll power off. Have to do a small modification for 7402. Okay, so what is that modification here? I can do even without fixing the IC and I'll fix at the right spot. Okay, so pin number 1 is not pin number 1 is the pin number 1 has to go here. Pin number 2 and 3 should get the input, right? So what I do, I move one pin number. See, I moved one pin here and this is coming from pin number 1. So my pin number 1 of the IC should go to this point where the blue wire is, and these two are the inputs from the switches. So 2 and 3 would go here for 7402. This is 7402.
Ma'am, do we have to attach all the photos in the lab sheet?
Yeah, I think there is no space, right, this time. In the result sheet, do you have space for attaching the?
So only the lab report.
The lab report is the same, like for the editable one that is available now. The result sheet. Wait a second, I'll check. At the bottom, is there any space for attaching the shots? Insert your drawing here, it says, but it doesn't say about the pictures. So don't worry, leave it out. Don't have to attach the pictures because there is no space.
Okay, ma'am.
But there are questions, answer them and submit the lab report. The assignment folder.
Also, ma'am, the lab 0 has marks or no?
No.
Okay. But we have to submit it, right?
No.
Okay.
And whenever you're fixing the ICs, remember that the groove should be onto the left like this, the way I'm keeping. Here is the groove, I didn't change it. See this way? Okay. So now we will. Now I have fixed 7402. Okay. Now I'm checking the output. The low in the input of NOR gate would force the output to a 1. Previously with OR gate, no, 1, see, okay. 0 and 0 is 1, okay. If I have a 1 in any of the inputs, a 0, 1. If I have 1 in any of the inputs, the output is forced to a 0, okay. 1 in any of the inputs of the OR gate was forcing the output to a 1 now. 1 in the input is forcing the output to a low. So 0, 1. Next is 1, 0. 1, 0 is 0. 1, 1. Both open is a 0 also. So NOR gate also I have checked. Now show me one by one all the parts, like all the ICs I have checked, but I didn't go for connecting the other part of the circuit. Now I want to check if your work is all done properly.